Hello, today is Monday and we are going to do a second day of lesson 4. We need to do a reteach because after the teachers had a chance to evaluate how things went on Thursday, we decided that this particular lesson needed to have a second day. So hopefully when you were in on Friday doing your testing, you were able to pick up this reteach page. Your teacher should have given it to you at your appointment when you came in to do your testing. If not, you're going to have to use paper and pencil at home because we are not going to move on to lesson 5 until tomorrow. So I would strongly encourage you to go back and rewatch lesson 4 with Mrs. Chin again today, just so that you get a good firm foundation in what we are doing with compensation, with adding and subtracting. The problem set that we're going to be doing is very similar to the one that you did on Thursday, and hopefully we can get this concept cemented in just a little bit tighter after we do another reteach today. So I'm going to encourage you to go back and rewatch lesson 4 with Mrs. Chin. Then you are going to try the problems, for subtraction and addition using the tape models that they demonstrated on the video. So you're going to be doing 4 problems of subtraction, and I have put in, or we have as teachers have put in the tape model so you can see what you're doing. And then you'll also need to do the same thing with the next set of problems, which there's also 4 addition problems that you need to practice with. Make sure that you draw and label the tape diagram to add tens, and then make sure that you also write a new number sentence. If you want to go back and relook at what you did on on Thursday, that might be helpful as well. And then you do have an exit ticket that your teachers would like to see. You have the same kind of a problem with an addition problem and a subtraction problem. And you also have another word problem that you're going to need to do as well. I'm going to remind you on the word problem that whenever you have a word problem such as this, you need to make sure that you're using cubes, that you're using read, draw, and write. And it's the right part that so many of you are still having trouble with. Several of my distance students forgot that when you do a word problem, we also need to have a word answer. So you do need to write a statement that matches this story. So you're thinking about circling the numbers, underlining the question, boxing the keywords, Xing out extra information, and setting up the problem to solve. And of course, you need to read. You're going to be doing some drawing, and you're going to be doing some writing. So when you have that done, you are going to send this to your teacher. Yep, you got to send it to your teacher so we can see how you are doing. If you were really successful with the lesson on Thursday, that's great. And this will just be really easy for you to do. If you were struggling just a little bit with the lesson on Thursday, hopefully another day of practicing these concepts will help you before we move on to lesson 5. So I'm going to ask you now, you're going to pause the video or come back to the video if you'd like, and after you've worked these problems, and I will show you the answer key. So you guys have a really good experience. I hope that the reteach will give you another opportunity to practice compensation just a little bit more. I think it will be helpful not only for our distance learning students, but also for our students here in our face-to-face classes. So have a great day, and pause the video. Okay, I hope you're back. Here we go. Let's take a look at the key. This was for today's lesson. As you were looking at this problem, you were thinking that if you would, in compensation, if you add the same number to both numbers in your subtraction sentence, if I add 1 to 43 and add 1 to 9, that is not going to change my difference. The difference will always remain the same. No matter what I add, the difference will remain the same. I get a new equation, which is easier to solve, more simple to solve than 43 take away 9. So I added 1 to 9 so I could get a multiple of 10, which was 10. I added 1 to 43 to get 44, and then I had a new equation. 44 plus 10 is much easier to do because I'm working with a multiple of 10. 4 10s and 1 10. 4 10s take away 3 10s. Oh, brother, misstar. Here we go. 4 10s take away 1 10 is 3 10s, and 4 1s take away 0 1s is 4 1s. So my new number sentence is this one right here. Because 43 take away 9 has a value of 34, so does 44 take away 10 have a value of 44. And of course, the difference between both of those problems is 44. Each of these equations have the same value. The difference is this one is easier to work. Hopefully you're beginning to see that and you're beginning to understand that better. Let's take a look at problem B. The same thing. I was looking at 32 and 17 and deciding what I needed to add to get to a multiple of 10 quickly. If I added 3 to 17, I could get myself to 20. So I decided that I was going to add 3 to 17. I'm also going to add 3 to 32. When I add 3 to 32, I got 35, showing that with my brackets. When I added 3 to 17, I got 20, creating a new number sentence that's much easier to work than the original problem. I love math. So 3 10s take away 2 10s is 1 10, and 5 1s take away 0 1s is 5 1s. All three of these expressions have the same value of 15, which is why we have an equal sign in between each one of these equations or expressions. All right, so let's go ahead and look at the next page. Here we are. And again, I'm going to let you take a look at this. I decided to add 2 to 28 so I could get 30, which meant I also had to add 2 to 60, which I did in my tape diagram. So 60 plus 2 is 62. 28 plus 2 is 30. That makes that so much easier to work. In fact, I can just about do it in my head. 6 10s take away 3 10s is 3 10s. 2 1s take away 0 1s is 2 1s, making each one of these expressions have the same value of 32, which is, I don't know about you, but I'd rather do an easier problem that I can do in my head than one that I have to write down. I'm finding this to be very useful to me too. All right, and on letter D, I could see that I needed to add 2 to 38 to get a multiple of 10, which was 40. If I do it to 2 or to 30, I also have to do it to 56. So 56 plus 2 gives me 58. 38 plus 2 gives me 40. If I compensate and I do the same thing on both equation or both numbers, my difference will always be the same. So much easier to subtract 58, take away 40, which gave me 18. Each part of this expression has a value of 18, which is why we are using an equal sign between these three expressions. All right, let's move on to the addition. So as we're looking at addition, we're trying to figure out, we can't change the value of 39 plus 56, but we can break it apart in different ways to make it easier to add. So when I was looking at this problem, I thought, well, I need to add 1 to 39 so that I can get 40. That's my goal. But if I take 1 from here, I am going to have to take 1 from here. So I'm taking 1 and adding it to 39 to get 40. So here that is, 39 plus 1 gives me 40. That only leaves me with 55 for the other part of my tape model. So I'm just rearranging how I have all of those numbers. I'm sliding 1 out of 56 over into 39 so that it creates a new equation that's much easier to work. 49 plus 55 is much easier to do in my head than 39 plus 56. 4 tens plus 5 tens is 9 tens. 0 ones plus 5 ones is 5 ones. Therefore, 45 plus 55, or 40 plus 55 is 95. Each one of these equations has the same value of 95. All I did was rearrange how I was using these numbers. The value did not change simply because I took one from here and added it there. Oh, look at that. I even have the standard algorithm, which I really don't want to have on there. That's my bad. Okay. Alrighty, so, yep, I got rid of my standard algorithm. I think I did that just to double check that I was on the right track, because that was the way I learned how to do math for a long time, and sometimes I just use that to double check that I'm on the right track. But please, parents, remember that doing the standard algorithm at this point is not what we're trying to help our second graders learn how to do. We're trying to teach them how to use compensation so that they can utilize mental math more frequently. All right, so let's take a look at problem B. I was thinking about, I had to change one of my numbers here to 24, which is what is on your paper. So 68 plus 24. If I break this apart and I push 2 over to 68, I'm adding 2 to 68, that gives me 70. So 68 plus 2 gives me 70, which is a multiple of 10, but that only leaves me 22 to put over here. 70 plus 22 is a much easier equation to work with than 68 plus 24. So hopefully you're getting to see that each one of these equations has the same value, which is 92, meaning they are all equivalent or equal to each other. They have the same value. All we're doing is rearranging how we're lining those numbers up, taking from 1 to make another number that's a multiple of 10, taking that away so that it's easier to add with multiples of 10. All right, so let's take a look at the next two problems. We have 72 plus 27. First question I want to ask myself is how could I get to a multiple of 10 quickly? And I thought, well, if I add 3 to 27, I will get to a multiple of 10, which would be 30. So if I did that, that means I'm going to break 72 apart into 69 and 3. I'm going to take 69 and 3 and create 30, which I did here. 27 plus 3 equals 30, but I had to take that 3 away from the 69, or away from the 72, which left me with just 69. So much easier to add 69 and 30 because I have 9 ones, take away 0 1, or 9 ones plus 0 ones gives me 9 ones, and 6 tens plus 3 tens gives me 9 tens. And all three parts of that equation have the same value. The only thing that I did was rearrange numbers so that I could get a multiple of 10, which is easier to do in my head. And if you get really good at this, you won't have to write it all down all the time. But for right now, I think writing it down is probably a good idea. People who are really good at math often do math using these particular strategies. Now let's take a look at the last problem, which is D. We have 27 plus 66, and my first thought was, well, if I added 3 to 27, I would get 30. That would mean 66 would have to go down by 3, which would give me 63. A much easier problem to work. So on my tape model, I have 27 plus that 3. See how I've included that 3? Is going to be 30. That leaves me with 63 for this part. 63 without that, or 66 without that 3 is 63. And 0 ones plus 3 ones is 3 ones. 3 tens plus 6 tens is 9 tens, making all parts of these equations have the same value, which is 93, and they are equivalent to each other. The thing that I like about it is this problem is so much easier to work than the original problem, which was 27 plus 66. I haven't changed or added to or taken away any numbers. It's still the same numbers, just rearranged to make groups of 30. because it's so much easier to add using tens. And with that, I am going to tell you that you will need now, I'm hoping that you'll have a better experience with the exit ticket. So make sure that you get the exit ticket sent to your teacher, and we'll see if you did better. I hope that you do. Have a great day of learning.